Alright, so my name is Phil Conrad, and I'm going to try my very first Khan Academy style video here, and I'm going to be talking about divisibility. Divisibility is something that is important in and of itself. It has to do with prime numbers, and prime numbers have a lot to do with how security algorithms work. But we're using it in this course, course in discrete math, simply as something that is easy to understand so that we can get started with talking about proof techniques. So divisibility, we write D divides N. That's the notation for D divides N. And what that means, D divides N, is that if D is not equal to 0, first of all, we can't even talk about D divides N if D is 0. If D is not equal to 0, then there is an integer k. There is an integer k such that n equals D times k. Now, another way to say that is that if we take n and divide it by D, the result is going to be an integer. So you can see here that if I divide both sides of this equation, n equals dk, if I divide both sides by d, let me just rewrite that over here, n equals dk, and if I divide both sides by d, then here the d's are going to cancel, and I just get this over here, n over d equals k. And we've already said that k is an integer. So since we know that k is an integer, n divided by d equals k, d divides n if, when I divide n by d, I get an integer. So let's take a look at some examples of that. Basically, if we are to ask ourselves, okay, does 3 divide 9? And the answer is yes. One way of looking at that is to say, well, 9 divided by 3 is 3, and 3 is an integer, so 3 divides 9. Does 3 divide 6? Yes, it does, because 6 divided by 3 gives me 2. 2 is an integer, so 3 divides 6. Does 5 divide 11? Well, the answer here is no, because if I take 11 and divide it by 5, I get, oh goodness gracious, what do I get? Well, I guess I get 2.2, which is not an integer, so you can see that my trackpad technique here is a little rudimentary. I still don't quite have this down, but I hope with practice it will get better. In any case, we can see that 5 does not divide 11, because 11 divided by 5 does not give us an integer. So those are just some quick examples to show what we mean by divisibility. Now notice in this case what I've done is I've actually done the division. We're going to find that when we do proofs with divisibility, it's better to stick with this original definition where we actually just use multiplication. That is, we're going to say, if we want to ask, for example, does 3 divide 12? What we're going to ask ourselves is, ask, is there an integer k such that, and we're going to abbreviate such that throughout our proofs and throughout all of pretty much math and computer science we're doing proofs, abbreviate such that as ST. That's going to be equal to, that's going to be an abbreviation for such that. So ST is such that. I'll just write that here so we know what that means. Is there an integer k such that, and let's go back and take a look at our original definition for a moment, such that n equals dk. Such that n equals dk. Now, our original definition, d is the number on the left, n is the number on the right. So what we're asking here is there an integer k such that 12 equals 3 times k? And yes, there is. That integer is 4. Now, all of this so far, I'm hoping, seems pretty obvious. Sorry for that little pop-up there. I'm still getting used to how to do this. If I hit the wrong place, that little pop-up comes, and hopefully we'll just get rid of that. There we go. Yes, in this case, the k is equal to 4. This seems pretty basic, but when we get into proofs of theorems like this one, if x squared is odd, then x is odd, or more to the point, if we're talking about divisibility, a theorem like, let me just change color here since this is a different theorem. If n is an integer, then n squared plus 2 is divisible by 4. Divisible by 4. When we get into theorems like that, we're going to really need this, this formalism. There is an integer k such that n equals dk. When we're just talking about simple numbers like 3, 4, and 12, that's going to be pretty obvious. But we're going to need that formalism a little bit later, so I want us to get used to it. All right, so that is just a basic introduction to the notation of divisibility. In our next video, we'll take a look at a divisibility proof and maybe also some proofs involving odd and even. Odd and even, of course, even means divisible by 2. Odd means it's divisible by, well, odd means that it's of the form 2n plus 1 for some number. So they're both related to the concept of divisibility, and we can use odd, even, and divisibility to just get used to the way that different proofs are done. So that'll be for our next video. Hope you enjoyed this, my very first attempt at a sort of a Salman Khan style, Khan Academy style screencast. I hope they will get better and that my handwriting will improve as I get more used to this whole technology. All right, thanks for watching.